Hello guys, welcome back to part 2, where we start off the discussion on the central subject in mathematics, which is called functions. Um, Functions are relations, simply put, and we want to demonstrate visually what relations actually are. And they start in a very simplified way, with a simple thing, with an idea of you choosing a point on the Cartesian plane. Now, realize that this point was not there. It was just an empty space. Actually, there are billions of points, coordinates. Everywhere a point is a point. It's a coordinate. But me highlighting one, or us highlighting one, starts off a very important, like this one, starts off a very important thing called relation. Where's the relation? In Zulu, relation is called uklo. You started off uklo, between what and what, or skotsi in Sesotho or Sepedi. Between what and what? Well, between the x and the y. Well, which x and y? Well, in this case, it will be this x with this y. I'm just drawing the line so that, because I don't have a graph paper, which has got horizontal lines and vertical lines, a mesh. If I could do that, otherwise this thing will be messy. Right. This point. And because we are highlighting this point, it means we're interested in it. But our interest in this point has started the relation now, where we're relating the value of 3 to the value of 2. So by convention, when we highlight a point, meaning we give it what is called a coordinate, we start with the x value it's associated with, and the y value, the corresponding y value, the corresponding y value. In other words, for this one, it will be 3, 2. This combination, x and y, whenever you see it relative to how you labeled your x's, you see, I can't call it anything else. If I were to say this point is AB, I would literally be asking you to calculate what A is and what B is, meaning you have to know where to find it here. So if you have a mesh called a graph paper, it will tell you what the value of A is. Stating it this way in terms of x and y is a generalization that it is a relation. Another way of stating the same fact, where now a thing, let's call it a thing for now, it's going to be called a function, right? It says, I've got many points that I'm interested in. The thing, it is saying it's got many points that it's interested in. This is us interested in one point. That thing that says that it's interested in many points is called a function. Let's make one example. There's an x, there's an y. And it's important that it's got to be written in terms of y, meaning we solved for y. Everything else exists on the other side. Now you say, well, this is an equation. You are correct. Right? Now let me introduce you to terminology now. This guy here is an expression. Why am I calling him? It's just terminology so that you get used to this. Because he's got terms. This is a term, this is a term. It's got two terms. It's an expression. An expression in terms of x. In the context of a Cartesian, it's called a function. This guy contains an x. This x. Therefore, he's a function. He's the guy that is going to relate. So we use the word f. We use the word f for the first letter to state that he's a function in terms of the primary. I remind us that the x is the primary variable, right? Or the primary axis. It's a label for the primary axis. So we state him as f of x is equals to, and we explicitly state him, there he is, as that expression, 2x plus 3. Now this is the guy that's going to do the relation for us, the relating. He's going to relate a certain value of x, right, with whatever is going to be the value of y. He's actually going to calculate the value of y for us. He produces function values. He produces function values. This one. This one. Another notation is to say y of x is to put everything together. That is 2x plus 3. In this notation, we're stating that y is actually dependent on x. This one, it's not just there because it's there, because we've drawn it. No. The value, this value, is dependent on this value. And because these are function values produced, calculated for us by this guy, by the function, we have to give the function a value for x independent, thus calling this variable an independent variable. It's an independent variable. Variable because it changes. And it's primary because a lot of activities is happening here. Well, actually, we can choose whatever we want, but activities are happening in the function value, in the values of the function. Meaning there's going to be arithmetic that obeys the Bodmer's rule to do a calculation for us using arithmetic operators. There's a multiply here, 2 times x. 2 times x, there's a times in the middle here. Meaning I have to start with the multiplication using the Bodmer's rule, B-O-D, Bodmer's. Bodmer's. Where the M stands for multiplication and the A stands for addition, meaning I have to start with the multiplication. And whatever the function produces for that value of x that we've chosen, whatever the function produces is going to give it to the value of y. That's the one that produces function values, hence function. It's a nice combination of words actually. Function values are produced by functions. Functions relate your choice to that value that it calculates, meaning these guys. Period.